for GitHub. So some of you might be using GitHub. It's a hosted Git, it's a Git hosting solution. And I also do some other stuff in the Git community. So for one thing, I'm the maintainer of GitSCM.com, which is sort of the main website for Git. And this is a pretty good resource for you. So if you're new to Git, this talk will be basically focused on people that are relatively new to Git. If you've been using it for a while, hopefully you can learn some stuff. But this is really an introduction to Git. So GitSCM.com is one of the main websites for Git, and it's a good place to find information on it. It's a good place to download Git. And so if you go to the documentation tab, there's a whole bunch of good tutorials and reference materials and links to books and whatnot, videos. There's Randall, saw him in the chat room. And there's a command listing that shows what all of sort of the basic Porcelain commands do. So we're going to be going over most of these today, and that's about it. Most of what I'll be doing is doing stuff on the command line so you can see how it works, and that's how today's going to go. So after the thing, if you want to figure out, what the commands we went over and what they do, there's a pretty good little reference here under the documentation tab of GitSCM.com. I'm the maintainer of this website, so if you see anything wrong with the website or you have suggestions on how to make it better or something, go ahead and email me. My email address is schacon@gmail.com. So if you need anything, if you have any suggestions on anything or you have any questions, go ahead and email me at that. The other thing that I've done recently is I published a book called Pro Git, and the reason that I'm sharing this with you is because the book is Creative Commons licensed and it is online. So if you want to learn more about Git afterwards, after this 1 hour introduction, then you can go to progit.org, and the whole book is online, and you can read through the book or a translation if you're from one of those countries. So that's where to go after this is over. So let's get started. The first thing I'm going to do is I'm going to show you how to set up a Git user. So what you're going to want to do is go to the download tab here. There's a whole bunch of different ways of getting Git. So you want to get Git on your system somehow. But once it's on your system, you need to set it up. So what I'm going to do is, so if I'm a new user and I have Git on my system and nothing's set up yet, the first thing that I want to do is I want to say git config -- global. And then I want to set up my user.name, and I want to set up my user.email. And these things are going to be used when you're doing your commit messages. So these things are going to be used when you're doing your commit messages. So as you're making your commit, this information is what's going to be recorded in your commit. So it's very important that you set this up when you're first starting off in Git. The -- global means that it keeps these values in your .git config file in your home directory. And so that means that wherever you're using Git, in any of the projects, these are going to be your defaults. You can override these in specific repositories if you want to by leaving out the -- global when you're in those repositories. But this is how you set it up. So you want to do this first. And then once that's done, another common config setting that you might want to set is color.ui. And what that's going to do is turn on coloring. So when you're actually running Git commands, you can see some automatic coloring. We'll see that when I'm running my commands because I have that set, but that's another setting that you're probably going to want to set off the bat. So basically, that's all you need to do to get set up with Git. So now you're ready to use it, right? So let's do some basic Git stuff. Okay. So here I'm going to go into. There's a couple different ways that you can get Git repositories. One way is to clone it, right? So this is a very common way if you're trying to start into a project that you haven't been working on or something. Generally, you'll go to a website, some Git hosting website. So this is, GitHub. This is a private installation of GitHub. But you can go to github.com, or you can go to repo.org.cz, or you can have a Git web installation, at your work or something. But they're always going to have this clone URL of some sort, right? So if we copy this, the thing that we'll do is we'll say Git Clone. And Git Clone will pull down a copy of the repository. And all you do is you just give it whatever URL web interface that you have, right? So if we say git clone this, it's going to clone down. This is what a clone looks like. And then we'll have a copy of this. Now, this is a lot different than Subversion if you're used to Subversion in that you get an entire copy of the repository. You don't just get the last checkout, the last version of whatever the project is. If we go into the Git repository, we can run a log, right? You can see how fast that is compared to like Subversion or something. And we can go through the whole history of this project. We have one checkout, but we actually have the entire copy of the repository. So one of the cool things about Git is that everything happens locally. Almost every command that you run actually runs on your local database that you clone down. It doesn't go over the network. You don't have network latency. You can work offline. Everything's really fast. Some of the advantages of Git. So that's one way that we can get a Git repository, right? The other way that we can get a Git repository is to create one. So if we're starting a new project, right? Let's say we're starting a Rails project. We'll create a new Rails project. The way that we make a Git repository out of this, you can see that this is not a Git repository, right? We just created the directory. We just created the project in it. We want to add it to Git. So the way that we do that is we just say git init. And git init will create a new Git repository. And you can see that there's nothing in here, right? But we do actually have a Git repository now, right? So we don't have any commits, we don't have anything, but we have a Git repository. So this is actually a Git repository. So those are two different ways that you'll generally you'll get a Git repository. You either clone it or you'll run git init in a new directory and you'll have one. So that's how you obtain one. So let's actually start doing some work, right? So much like most other source control systems that you're using, in order to start adding files to it, you need to start tracking them, right? So in Git, we have untracked files. So these are all the files in the file system right now in our project that we just created that are not tracked by our system yet. So in order to start tracking them, we have to run git add. And this is similar to like svn add or material add or something like that. So we're going to do git add dot, which will recursively add the whole directory, which isn't generally what you want to do. Generally what you want to do is git add individual files, but just for the sake of getting this done, we'll do that. And we can see if we run git status again, that all of these files are now new in here, right? It's tracking them now. You can see them in green, which will happen if you run the git config color.ui setting, and we can commit it. Okay, so all of those files are now tracked. We can do our commit now. So we can just do a -m on the command line to do our initial commit message. And that's it. Now if we run git log, we can see that we have one commit. And if we run git status, we can see that our working branch is clean, right? So now we've added all our files. We've done our commit. We have a repository with a commit in it. So let's go back to our Git repository. Another sort of useful basic command at this point is you can just run git show, and it'll show you what your last commit was, right? So this is the last commit on the branch here, and we can actually see what the diff was as well, but git show is a nice way of seeing sort of where you are currently. Git log is another useful one that you've seen that I've done a couple times already, and this just gives you your commit log, right? The top one is going to be your latest one. This is the same commit that we just saw with git show minus the patch, and then the one before that and the one before that, and so on, so as they get older. So let's do some work now. So just to go over sort of what we had done before, we have for new files, they're going to be sort of untracked. Git will see them as untracked, and we have to add the file with git add. And then once we commit them, everything's going to be unmodified. So right now, all of our files are unmodified. So if we run git status, we'll see that there's nothing because all of our files are unmodified. As soon as we start modifying stuff, we'll have files in the modified stuff. And now I'm going to introduce you to a new concept, which is the staging area. And so in order to do that, I'm going to apply some changes that I've already sort of pre-done here. So this basically just changed 3 files, right? So if I had gone in and I had actually edited the 3 files manually, this is what we would see. When we run git status, we can see that we've modified these 3 files now. So I've done some work. I've done a clone or whatever. I've done some work on some files, and I want to commit them. So there's a couple different ways that we can do this. Okay. The first way, and sort of the easiest way, especially for people that are used to Subversion, is you can just say git commit -a, and what that's going to do is that's going to take everything that's already tracked and has been modified, and it's going to automatically stage it for a commit, right? So I can do this, and I can say my commit, and I can commit it. Okay, so that's one way. Now, I just rewound that, so let's try a different one. Another way to do it is you can stage files individually, right? So this is similar to, like in Mercurial or Subversion, I believe you can do commit and then give it a file name, right? So if I just want to commit the rake file, the changes that I made to the rake file and not to the other files, I can do this. So let's undo that. I don't want to do that. The other way that you can do it is you can use what's called a staging environment, a staging area in Git. And so what I can do is I can stage changes to files individually, and then I can commit just the files that I've staged. So the way that you stage files is you use git add again. So git add begins tracking files for modification, and it stages files for commits. So I can say I want to stage the changes that I made to the rake file, and if I see status, I can see that my rake file has been staged. So if I were to run git commit right now, it would be sort of similar to just saying git commit rake file, right? Just saying I just want to commit the changes to this one file. But I can keep doing that. So I can say git add lib grit. And now if I run git commit, it'll just commit the changes to these two files and not to this one down here. So this is a little bit of a different concept. There aren't very many source control systems that do this way, but it's really nice in that you can craft the commits that you want to do. So if you've been working all weekend on something and you have a couple of separate commits and you want to make it, 3 or 4 different commits, which is really helpful for things like peer review and things of that nature, to make it easier on people trying to see what your history looks like or what your patches that you're introducing look like. You can craft your commits by using git add to stage changes and then running git commit to commit them, right? And when you run git commit, it opens you into whatever your default editor is, and it gives you everything with a hash mark will be left out of the commit message, but it'll show you what files are going in to this commit and what files have been modified in your working directory but are being left out of this commit. So it gives you sort of a nice overview of what's happening. If you do no commit message and just exit, it'll abort it, right? So some other useful things is that Git status will tell you, the newer versions of Git status will tell you how to do some common stuff. So if you want to unstage some of these, it'll tell you how to do that, right? So if I want to unstage my rake file, I can unstage that, and now only the changes to grit is in there, and I can run git commit at this point and just commit the changes to my grit file here. Some other really cool things that we can do. Some other really cool things that we can do with the staging area is we can actually, Git will allow us to stage hunks of files. So, for example, actually real fast, let me back up a little bit. If we want to see what are in these files, what changes we've made in these files, the command to do that is git diff. So if you do git diff with no arguments and you just run it, it's going to show you not just which files are unstaged and we've made changes to, but it'll show us the patches, right? So it'll show us in our rake file we've added this, and we've changed this, and we've removed this, right? And in our grit.gemspec, we've changed these two things, and in our grit.rb, we've changed this one thing, right? So that's actually what is unstaged. If we want to stage patches, if we actually want to, so let's say I want to commit this change because that's done and tested, but I don't necessarily want to commit these changes, right? You can actually do that with Git. So the way that you do that is you do git add-p, and that's for patch. You want to add patches. And that's going to go through, and for each hunk of each file that you've modified, it's going to show you the hunk, and then it's going to say, do you want to stage it, right? And so I can say, yes, I want to stage that one. And then it gives you another one, says, do you want to stage this one? and you can say, no, I don't want to do that one, and it says, do you want to stage this one? And I want to say, no, I don't want to stage that one. No, no, right? And then if I run git status, this is sort of interesting. You can see that part of the rake file has been staged and part of the rake file is not staged. So if I run git commit at this point, it's only going to commit the changes that I staged with that git add-p. The other useful thing for git diff is --cached or --staged you can do in the newer versions. And that will show you the diff of what's staged, right? So this is what's going to go, that's all right there. So this is what's going to go into my commit, that change right now. If I run git commit right now, that's the only change from the last commit that's going to go in. The other changes in my working directory aren't, right? So this gives you this really nice place of setting up your commits and crafting them to exactly what you want to share with people and how people can peer review your work easily. So this is incredibly useful for things like if you've made a whole bunch of changes to a file and some of them, say, are documentation related or white space changes or something, and some of them are actual business logic code changes, but there's like 100 changes, right? You want to split that out into just the documentation stuff and then just the business logic stuff so that, especially if it's a really high ratio, like 90% documentation, white space changes and stuff, and like 5% business logic, or 10. I forgot what the first number I said. But you want to do that so that it's easier for people to review that, right, to look through that instead of having to just scroll through some huge diff of a whole bunch of white space changes. So this can be really, really helpful to people and to teams for figuring out what's happening in a logical manner. Git makes it really easy to make these decisions sort of at the last minute, right? So that's very cool. So let's see. So if I just run git commit right now, it's just going to take that change that I did. When I exit out of the editor, it does that. If you want to use a different editor, you can just export your editor environment variable, which you probably already have set if you're using something like Emacs. The other thing you can do is git config, and again, you want to do global, so it's always in place, not just for this one repository, core.editor, Emacs or something like that, and that'll use it so that it'll fire up Emacs. I would do this, but I wouldn't remember how to exit Emacs again. Okay. All right, so the other thing you can do, so now we have changes to these files still, the remainder of the rake file that we didn't stage, and then these changes. If you want to use Git the same way that you would use Subversion, you can say git commit -a, and that automatically stages everything for your commit, right? So I can say -a and then -m, the rest. And now everything's committed, right? So that is basically the local operations that you do for, the local operations that you do in Git, right? You'll add files to be tracked, and then you'll edit them, and then you'll stage them, and then when you commit them, the status of those goes back to unmodified. And that's the basic life cycle of Git, right? So, let's see. I went through log, I went through diff. Another useful log command is --stat. That will show you for each commit what files you've changed, right? It'll give you a nice little summary of what happened in that commit. So I can see that what I did on these 3 files, and then the one before that, I just had some changes to my one rake file that I had done, and we can go back and see what has changed in each commit. And by default, Git will run git log through a pager, so you can just hit spacebar and continue paging through all of these commits. All right, so now I have a clean working directory. So now let's see, I'm going to go through some branching stuff, okay? So one of the really cool things about Git is its branching mechanism. So I'm going to go back to my test directory here. And again, I'll just have that one commit, right, that I did when I imported the project. So let's actually take a look at this. Okay, so this is showing this page right here. All right, so let's say that we're developing this. One of the cool things in Git is its branching system. And in order to understand its branching system, if you're coming from a system like Subversion, what you probably want to do is forget everything that you knew about branching, because Git's branching system is used very differently, generally on a day-to-day basis, than Subversion's branching system. You can use it for sort of the same things, but it's so much easier and faster to use that you can use it a lot differently. So I'm going to show you an example of how to do that. So one thing about Git's branching system is that it's very common to create a branch for each small topic that you're working on. So if you're using a story-based system or a ticket-based system, that you can create branches for the ticket and then just do the work for that ticket in that branch and then merge it in when it's completed. And so you can have dozens of small branches open at the same time. These are generally referred to as topic branches. And you can do your work in those topic branches and then merge them in when they're ready. So you don't just do big stuff in branches. You do really little stuff in branches. So let's create a branch. The main Git branching mechanism command is git branch, and by default it will just list you out the branches that you have and show you which one you're currently on. So I'm on my master branch. That's sort of the trunk of Git, right? But I can create new ones really easily. So let's say I want to I want to create a new branch called testing just to test out some stuff, and I don't want to mess up my main line, but I want to test out some stuff. I want to see if it's going to work out well or not. So I can say git branch testing, and if I run git branch again, I can see that I have a new branch called testing, right? So let's switch to it. The way that you switch branches in Git is git checkout, so I can say git checkout testing. And now if I run git branch, I can see that I'm on my testing branch, right? So now new commits that I do in this repository are going to go into that branch, right? So let's go in here and we'll change the background color to something really beautiful. So basically what's happened here is we've had these certain commits. So this is first commit, second commit. This isn't exactly what I had here, but and we have a pointer to the last commit that we're on. And when we create a new branch, it just creates a new pointer to the same exact place, right? Master and testing point to the same place. The other way that we can see this is if we run, there's a TCL/TK, a TCL/TK program called Git K that you can run that's distributed with Git, and it'll show us a visualization of the same thing, right? We have our one commit, and we have our master branch pointing to it, and our testing branch pointing to the same place. So let's actually create some changes here. So I changed my background color, and if I look at the status, I can see that it's changed. If I run git diff, I can see what changed. If I run git commit -a, I can say changed the background. Okay, so now let's look at git k, and we'll see something a little bit different. We can see that our master branch points to where we had started off, and our testing branch has actually moved forward, right, with our new commit. Okay, so that's kind of interesting. And we can also see that our background color has changed, right? All right. So now we want to, let's say we want to do this a little bit differently. We'll do something much, much prettier. That's nicer. I like that. And we'll do the same thing. Git commit -a, better background. And again, we can see that our master branch has stayed in one place, and our testing branch has moved forward with our new commit. Okay? Now, let's say that somebody else comes along and tells us that we need to change this welcome aboard to something else, right? But we're not sure if we want to keep this background color. So what we can do is we can say check out master, go back to our master branch, and you'll see that this actually edits our code in place, right? We have one working directory, and it's actually changed our code. You can see that revert to what it was before, right? So when we do checkout, it changes the files in our working directory in place. So we only have one working directory we're working with, and when we switch branches, it'll make it look like whatever the last commit on that branch was. So now we can create a new branch. The other way you can create a branch and switch to it at the same time is checkout -b. So we can either do git branch something and then check it out, or we can do checkout -b. So I'm going to do this, and we can say title, right? And we can see that we have our master branch, we have our testing branch, and then we have our new title branch that we're on right now, which should be at the same place as our master branch. We can verify that with -b, and it'll show us the last commit on each branch. We can see master and title are pointing to the same thing, right? So now we want to go to change that title, okay? So This is a Hawaiian website, so we're going to do that. And we'll commit that change. Now, we can see that our history has actually diverged a little bit. So we have our master branch. We had a couple commits done in our testing branch here, and then we have a title branch that's moved off in a different direction, right? So if we actually look at the website now, we can see that it's Aloha Aboard. And we can keep doing this, right? We can go back to our master branch, and that reverts the change that we just made to welcome aboard. And we can create new branches, or we can just do commits on here, right? So if on our main thing here, we actually wanted to say, instead of getting started, we wanted to say really getting going. We can do that, and we can just commit directly to our master branch. And once again, now we'll just have three different heads that we have, right? We have our title branch, our master branch has moved forward, title came from this original commit, and two commits on our testing branch. In the newer versions of Git, you can also do this. I actually like doing this. -- graph to log will actually show the commit graph. So we can see it in one nice place here. It'll do it in a little ASCII thing like that, which is kind of cool. All right, so now we have all this work in our different branches, and we want to merge it in. Okay, we want to merge all of these changes together, right? So we have our title change, we have the getting started change, and we have the background color change. Now, in our master branch, we have this really getting going that's already in there, but we want to pull in the title change because it's been approved, say, and we want to pull in the background change because it's been approved, right? So the way that you do that is you say git merge, and git merge will merge in other branches. So if we say git branch, we can see what branches we have. Say we want to merge in our title branch first, okay? And then we want to merge in our testing branch. There you go, right? So now all three of the changes that we made in our different branches are all merged together, and we can see them graphically as well, that we did those merges, right? So a little bit of a weird-looking history here, but this is a very common workflow in Git, is to create topic branches for topics, individual silos of work that you want to do, using Git checkout to context switch between those topics easily, and then merging them in whenever they're complete, right? And so that is the basic branching mechanism that you have in Git. And then when you're done, right, so now we're done with the testing branch and the title branch because we've already merged them in. We don't really need them anymore. I think you can do this. Yeah. So if you run git branch -- merge, that will actually show you all of the branches that have already been merged into whatever branch you're working on. So that means that they're sort of superfluous, right, because the work that they have has already been merged in, so you can get rid of them now. So if you say git branch -d testing, it gets rid of the branch, and title gets rid of the branch, and now all we have here is master. But you can see that all it really did is get rid of the pointers, right? We still have all the work is exactly the same. We just don't have those pointers in here anymore. So that's all that branching is in Git. It's creating pointers to the last work on the last commit on a specific branch. And as long as it's merged in, as long as it's reachable from some other branch, if you travel down these lines and you can get to the commit that some other branch points to, it's very easy to do that. Now, one of the other kind of cool things you can do, let's say that we wanted to go back here and branch off of this, we can create branches at sort of arbitrary points, right? So if I wanted to create a branch off of this one, off the getting going, I can create a branch at that point. I can say git branch, ticket 53 at that particular commit, and then you can actually see that it just created that branch there, right? And then I can switch to it, and I can start doing work. And again, this is going to revert to whatever that thing was. So at this point, we hadn't merged those other changes in. It was just this change, right? So it reverts back to whatever that point was, and I can keep working. off of that earlier point, right? So, anyways, I hope that this is helpful to you. The lightweight branching mechanism. Again, all of this is local, right? Everything that I've done so far is entirely local. There's been no network access for any of the commands that I've done other than clone so far. So all of this branching mechanism stuff is all for you. It's to help you organize your work in ways that make sense, that allow you to context switch back and forth between them and then merge them together when they're all ready. And it makes it really easy to do that. So now it's time to share this stuff, right? So now I want to collaborate a little bit. So I'm going to go in and log in as a different user. Okay, so now I'm Josie over here, and I'm going to push this up. So one of the cool things about Git is that it's not a centralized system. It's a distributed system. So there isn't one single central server that you have to deal with, right? There can be multiple. You can have a whole bunch of different servers, some of which you can write to, and some of which are read-only. So this is what we cloned Git from, right? But let's create a new account for this new project that we have going here. So I'm going to create a new repository. This is on GitHub. I mean, if you have GitWeb or whatever, however you create a project in whatever you're using as your Git hosting provider. So I'm just going to create a repository real fast. And I'm going to go in here and just copy these oops. Now, I push it up, and that's it. Right now I've shared my repository. I've pushed it up somewhere. So one of the interesting things is this command right here, which says I want to add a new remote server, a new remote repository. So it's sort of like Subversion Central Server, except you can have many of them, right? So I'm saying I want to identify a new one. I want to name it origin, and this is the URL for it, right? And then Git Push Origin Master says I want to push my master branch to the origin server, right? Which is a shorthand for this whole URL here. And it does that. It pushes that up, right? So if I go back to my server, my Git server that's on the internet, now I've pushed my work up to this sort of central server, and you can see that, right? And you can see all of the commits that I've done and stuff too. So now Josie wants to collaborate on this project, right? Just real quick, let me add her as a collaborator. Okay, now Josie can clone this, right? So now as a second person, you can come in and you can just go ahead and clone this. And now I can see the same files, right? So let's go in here and now Josie makes some change. And I can do the same thing. I can do push origin master. Now the reason I can do origin here, I had to add it manually over here, right? I had to actually specify that it was origin. And here I don't, is that Git assumes origin when you do a clone. So when you do a clone, what it's actually doing is it's creating a new directory and doing an init and adding a remote called origin with whatever URL you're cloning, and then fetching from it and checking it out. It actually does all that stuff for you. But by default, it gives you a remote named origin. You can actually check your remotes by saying remote-v, and that'll give you a list of your remotes. In this case, Josie has origin, and it points to this, right? And if I do get remote-v over here, I can see basically the same thing, right? I have origin, and it's that. But now, Josie has done some work and pushed it up, and we can actually see it over here, right? If we go to our central server, we can see that the last commit on here is the one that Josie just did, right? Okay. But Scott doesn't have it yet, right? My working directory is clean. I'm going to go back to my master branch. My working directory is clean. I don't have any work. I don't have Josie's fix yet, right? So how do I do that? There's a couple different ways you can do it. The one that I like to encourage people to use is one called Git Fetch. So if you say Git Fetch origin, right, because you can have multiple ones, I want to fetch the changes that are on my origin remote. it'll go out and it'll check to see if Origin has any work that you don't have yet, right? And if it does, it pulls it down, and it does something kind of interesting. There's a master branch on Origin, right, which is what we're looking at here. We're looking at, the master branch. And it pulls all the work down, but it doesn't mess up what you're doing, right? My branch hasn't changed. Nothing that I'm doing has changed. I'm still where I was before. This is not Josie's change, right? So it doesn't actually automatically merge it into what you have, right? There's a command called Git Pull that will do that, but I actually like to teach Git Fetch because it gives you a little bit better idea of what's actually happening. So if I look at Git Branch and I actually say -A, I can see all of the branches that I have, right? I have my master branch, which is the last merge that I did. I have that ticket 53 that I had branched off from an earlier point and did some work on. And then I have the master branch at the origin server, right? And this is Josie, right? This is the one that Josie did and pushed up. So this is interesting because I have her work, but it's not messing up my working directory. I can look at it separately. I can create a new branch at this point and check it out, see what's happening, right? So if I wanted to do that, I could say git checkout-b, Josie, see what she's doing, origin master. And now I have Josie's work, right? If I say git log, I can see that the last thing on here was Josie's work. I can see that the README was what Josie just changed it to, right? So I can see that. But if I go back to my master branch, that's not what's in my master branch, right? I didn't mess up my master branch, whatever I'm currently working on. I can look at it separately without actually having to destroy or modify the work that I'm working on. So this is really nice, right? So if I wanted to, I can merge it in. I can say git merge origin master, or I can say git merge Josie because they're both pointing at the same place. Or if I want to inspect it, I can say git log origin master. And then there's a cool thing you can do in Git, which is you can say --not and then master. And what this says is I want a log of everything that's in origin master that I don't already have merged into master, right? And so this will just show me the one commit that's unique to origin master that's not in my master branch yet. So if I merge, this is what's coming in. I can also say stuff like the --stat that I showed you before, right? That'll show me that what she did is mostly remove all the lines from README and just add one or add a little bit, and that's what the change is, right? So I say, okay, fine, I want to merge that in. So I can merge in origin master, and now if I run a log, I can see on my master branch that Josie's in there, right? And again, we can look at this visually as well. So this is where the master branch on my origin server is, this is where my master branch is, and this is where the Josie branch that I just made was. They're all the same place. So now the Josie branch is superfluous, so I'll just get rid of that. And that's it, right? And again, I can work, and I can do commits, and then I can go back to Josie, and she can, I'll show you a pull real fast to show you what the difference is between a fetch and a pull. So let's say that I edit the README now, and I run git push. And git push, again, will push my master. I can say git push origin master, which is more explicit. If you leave those off, it'll assume them. If you've done a clone, it already has the tracking branches set up. But in general, git push origin master is probably a better thing to teach because it's more explicit. I want to push my master branch to my origin server, but now it's pushed up. And now Josie can do the opposite, right? I could do git fetch and, again, look at origin master and merge it in if I want to, or I can just say git pull, and it does the same thing. It does a fetch, and then it does an automatic merge with origin master. So I can see that it actually did change my README file in place. I would encourage you to use the fetch and then explicitly merge model. That's what I think is a little bit safer, gives you a better idea of what's going on. It doesn't, if you have merge conflicts and stuff at this point, sometimes it's difficult to figure out what's happening. So I tend not to encourage that as much. But speaking of, so now if I run git log, I can see that it actually merged in Scott's changes, right? Josie running the git pull actually merged in Scott's changes automatically. So speaking of merge conflicts, let's see, where are we? I'm running out of time. Okay, so merge conflicts, when you do a merge conflict, what it does is it just puts in merge conflict normal markers that you would see like in Subversion or something. Let's see if a merge from 53. Nope. Okay. It'll just put in normal merge conflict resolution markers, the arrows to one side, like like this sort of thing, and then equal signs, and then the other side, and you just have to resolve that by hand, and then run git add on the file again to mark it as resolved, and then commit it, and that's it. It's a relatively simple process that you can probably. I mean, I'm running out of time, but you can read more about that in the git.org book if you want to, which again is free and online, so it's easy to do. Real fast, what I want to show you is let's see, how much more time do I have? Any?
Yeah, you can keep talking.
Okay.
There have been a lot of questions, but everyone is doing a great job of answering them, so I think people would like for you to carry on.
So let me just show a couple more things that I think are really interesting Git tools that I like a lot. One is, let me go back to the Grit project real fast for this. One is blame, and this is similar to SC and annotate, which is a really useful tool, right? But if we, let's say that I take some let's go into Grit. Let's say that I take some code from one file, right? This with timeout. This doesn't make any sense, but let's just say. And I want to put it into another. I'm refactoring, right? This thing doesn't belong here. It belongs right here. Okay? So I've taken some code from git.rb and I put it into blame.rb. Blame.rb is probably bad because I'm showing the blame command, but whatever. All right. So all right. So now there's a really cool command in Git called git blame and libgrit, and you can do this to any file that's in there. And what it's going to do basically is show you the last person to modify each line, right? So this is the last commit that touched this particular line of the file. This is the person that did that commit and the time they did that commit. And so you can go through here and you can see so here's the thing that I just pasted in, right? The self with timeout. So it was done today, just a couple minutes ago. Whoa, whoa, whoa. It was done today, just a couple minutes ago. Here it is. And it's different than these lines, right? So this was done 8 months ago, and then this whole block right here was just done right now. But that's actually, so this is kind of cool. This is similar to SC and annotate. But in this particular case, that's not that useful. Let's say that the issue with this, there's a bug in this code, right? And the issue is with this line right here. So why this information may not be helpful is that this shows me when I copied the code over, not who originally wrote this line, right? So that's a difficult problem, but Git actually makes it very easy to do that. If you run git blame and you say -C, it will actually show you not who last edited that line in this particular file, right? Here's our self with timeout, but where it originally came from, right? So the person that last touched this line actually changed the line, not moved it into another file, but actually changed the line was me, and it was it was 8 months ago, right? So this will actually go and it'll show you what file it came from. So this is pretty cool. This will actually show you who changed what lines, even if the code has been moved from one file to another. So that's git blame -C. It's a very cool and useful thing that I don't know of other source control systems that can do that sort of thing. The other really cool thing that you can do with this is let me look for something fun. I don't know. Let's say that this particular commit right here, that was the last one that I released out into production, right? Let's say, and I know that that it was good. And let's say that I just found a problem in this code right here, okay? And I don't know which commit in between all of these actually introduced that problem, right? So Git actually comes with a tool to help you figure that out. And it's called Git Bisector, and it's really cool. So let's say that this was the good one. So the way that you do that is you say git log, you say git bisect, start to start the bisecting engine. And then you say git bisect bad to say where I am right now is a bad commit. And then I say git bisect good, and I put in the SHA of the one that I know was good, right, which in this case is this one right here. So I'm putting in the SHA of the commit that I know was good. And then what it's going to do is it's going to take all the commits in between those points, and it's going to check out the middle one for you. And since it checks it out in your working directory, like I was showing you before, you can actually test it in line. So I can say, I can run rake or something and actually run the unit test and see if there's a problem. And if the unit test or whatever come back, or I test the problem and it's fine, I can say git bisect good. Okay, so that commit's fine. So then it'll take the remainder between that good one that you just marked and whatever the bad one, the last bad one it saw, and it checks out the middle one again, and you can say this one's still bad, and it keeps doing this, right? And you just tell it, this is a good build, this is a bad build, and eventually it's going to come up and say, all right, so based on all of your feedback, this particular commit is the first bad commit, and it shows you what the commit is so that you can, revert it or something. But there's a really nice way of finding out where a specific problem was introduced, right? And then when you're done, you can say git bisect restart or reset, and it goes back to wherever you were before, right? So this will reset me to whatever commit I was at before I started the bisecting process. But now I actually have the information to deal with whatever bug that I found, right? So this is very useful. I use this all the time. It's a really cool feature of Git. Okay, so I think that was everything that I wanted to show. So if there's any questions, I'd be happy to answer them.
That was amazing. So what about questions? Folks, I know a lot of questions have flown by. Why don't you, if you have a question for Scott, why don't you post it in the chat room right now and we'll ask him. Interacting with SVN repos.
Yeah, so that's a little bit outside of the scope of this probably. There is, I mean, if you want to read about it in depth, there's basically a whole chapter on this. Get another system, get version here. So basically what it is there's a git svn command that Git comes with, which is a bidirectional bridge to subversion. And so you can do stuff like you can do git svn clone and then give it, I think it's checkout. Sorry, checkout. Been using Git for a while. Git svn checkout and then give it a subversion URL. And you have to be careful with this because it takes a really long time. Generally, by default, it will check out all of them. And basically what it is it just does checkout version, 1, checkout version 2, checkout version 3, and do a git commit for each one. So it can take a super long time to do that. But once you have that done, you can do normal Git branching and normal Git stuff locally, and then you say git svn decommit to push that back up to the server, right? So there's just a couple of commands that you have to learn. It's a little bit different, but you can interact with the subversion server in a bidirectional manner with git svn, which can be nice if you're stuck on a subversion server in the meantime.
Hey, Scott, people are asking if they can get your book as a PDF. Is it available?
Yes.
That sounds qualified.
No, it is. I'm just trying to remember. I'm trying to remember where I put that. I'll probably put a link on this page at some point for that. There is one. If you download, if you go to the GitHub link here on the book, the source code of the book, the markdown source, is actually on GitHub. So if you want to contribute errata or translations or something, there's a whole bunch of translations started. But there's a LaTeX subdirectory, and somebody made a make PDF file. So if you actually want to deal with, compiling the PDF yourself, this is actually a really nice PDF. I have a generated version of it somewhere, but I don't remember where it is right now. I'll put it on the website or on the GitHub blog at some point to link to that. But you can generate yourself from this if you'd like to do that.
Okay, and then let me see. There are a couple questions. Mike was asking, do you have to use a unique name / email address for each computer that uses Git? Desktop, laptop.
No. You can use whatever you want. Actually, I was just helping somebody else out with fixing up the repository, and I just did a git config and did their name and email address and did all the work sort of as them, so it looked like them, it's doable. It doesn't authenticate that at all, right? It's just if somebody's merging your stuff in and it looks like they're spoofing into something, you don't have to merge their work in, but you can tell your local system that you're whoever you want. I set Scott Chacon at gmail.com as my username and email everywhere, and that works out fine because it doesn't really authenticate that for anything. So it doesn't really care what you put in there. It's just for other people to figure out who you're merging from.
Okay, and then I don't know if you have time to do this, but Mitch asked if you could show the steps to create a branch from a master one more time and then merge the changes back to the master.
Yeah, absolutely. So I'm on my master branch now, so I can say checkout -b issue 53, and that creates a new branch and checks it out, right? So you can also just say git branch issue 53, and then I can modify something, do a commit, and you can see issue 53 has moved forward, and master is still back here. Oh, by the way, that I do, I've set up an alias, and it's just this, right? So I just don't like typing up this whole thing, but I really like this view because I don't really like typing up or having git k run every time. But this will do, it's a one line per commit, and it does abbreviated commit, so I only get the first couple of characters, not the whole 40-character SHA, and it does the graph that I like, and it decorates them, so it shows me where my references are. So if you say git config alias.lol and then put this line there, then it'll set up that alias, and you can just run that and see where all your branches are, right? So let me go back to my master branch real fast and do something else. Okay. Now, if I run LOL, I can see that, sorry, I actually have to do --all, so it does all my heads. I can see that I've diverged, right? So this is my issue 53 change, and this is my, where master has moved forward. And now I can merge them together. Git merge issue 53. So I can merge issue 53 in. So this is an example of a merge conflict. I did that on purpose so you can see sort of what a merge conflict looks like real fast. So this is where the merge conflict is, right? So I can see the conflict here, and I can solve it by just solving it somehow, however you want to solve it, right? And then if I run git status, I can see what is still unresolved, right? So this readme.md, that was a merge conflict, and I have to actually mark it as resolved. And the way that you mark it is with git add. So git add has a whole bunch of purposes. But then when you run git status, you can see it's done. And then when you run git commit, then you can just commit that branch, and now you've merged it together, right? So I solved the conflict, and I finalized the merge, and now I can get rid of my issue 53 branch because I don't need it anymore. It's reachable, right?
Great. And we've had a couple questions, and I'm not sure. Someone asked for more clarity here, but people are asking, how is Git used in mobile development, and do you have examples of how it's being used?
Well, yeah. So, I mean, a huge thing on mobile development is Android, right?
Yeah.
So I've done a ton of training and stuff for Android because the Android project uses Git for all of their development, and so a lot of big mobile development companies are using Git to do specifically their Android development because it's such a huge project. It's a Linux kernel plus a whole crap ton else, right? That's a technical phrase, crap ton. But basically, so all of this is done via Git, and you can see this is a great example of a huge project in Git, and how they actually do that. So if you want to go through here, there's a whole bunch of documentation on how they actually do mobile development with Git, but it is certainly doable. So other questions? Does that answer that?
Can you hear? Oh, okay, sorry, my phone was muted. So people, one last question. They want to know about cherry picking, and I can't find the specific question, and no one has reposted it.
Yeah, that's fine. Cherry
Okay.
picking, I can show real fast.
Okay.
So, I mean, this isn't a great example of a here, actually, so what I'm going to do is I'm going to cheat a little bit. I'm going to rewind stuff. I'm going to undo this merge that I did. Oh, actually, sorry. Ignore everything that I'm doing right now. So I'm going to recreate the branch that I had deleted, and I'm going to reset my current branch back to where I was. Okay, so this is where I was before I'd done the merge, right? If I didn't want to merge this in, I actually wanted to just cherry pick this change, and that actually makes more sense. Sorry, check out. Here. Okay, so I'm on my master branch, right? And this person has done, like I say, I've pulled in a change, or I've done some commits on another branch. So in this case, issue 53 has 2 commits on it that I don't have yet, right? But I only want one of them, right? Let's say that I actually only want this one right here. I can cherry pick that. I can just take the patch that was introduced from in that particular commit, and I can try and reapply it on top of where I currently am. So I can say git cherry pick, and then the SHA, and that just introduces the change. And oh, sorry, I was already on that. Check out master. All right. All right. So if I say, let me try that again. Git cherry pick, and then the SHA that I want to cherry pick the change onto, and it actually does the cherry pick and gives me a new commit. And I can see that I took this change, right, this patch that was introduced here, and I just moved it over here, right? So if I just want to ignore this one, I'm sorry, other way around. I took this one and I moved it onto here. So if I just want to ignore this change altogether, and I've already cherry-picked this, I can just delete this branch now, lose this change because I don't want it, because I've already cherry-picked this one out of that series. The way that you do that is git branch -d issue 53 won't allow you to do that because you have, it's not an ancestor in your current head. You haven't merged it in. So you're going to lose work, right? And so you have to do a capital D to tell it, yes, I actually want to lose work. But I've cherry-picked the one change that I wanted, this something else change, this wasn't a great example because I named it both something else. These are actually two different changes, right? That's a little bit of a different change. So I cherry-picked this one on with cherry-picking the SHA name, and then just deleted the rest of the branch. So that's how you would normally use cherry-pick, is just pull patches one at a time.
Great. Well, we've gone over our hour. That was fantastic. That was amazing. So thank you very much, Scott. And I want to thank everyone else who joined us today. And thank you, guys, who are answering all the questions, Randall and a lot of others. You really helped. You did add a lot, so thank you for helping out. And if you want to keep a copy of the chat window, the chat transcript, the best way to do that is just to click in the window and select all and copy it. And or you can email me if you want to at webcast@o'reilly.com, and I can send it to you. We'll have a recording available afterwards. I'll send everyone, we'll send you an email with a link to the recording, and that's about it. If you don't click out too quickly, you'll see our post-event survey that appears, and I would really appreciate it if we could get some feedback from you on how this session ran and what you'd like to see in other webcasts. So that's about it. Thank you, everyone, and thank you again, Scott. That was great.
Thank you, guys.
I'm about to close out the meeting now, so there we go. All righty. Bye, everyone.